Alright, so what I'm going to do with this is I'm going to be building a CNC table out of this. And this is one of their 3x4s, but what I'm going to go ahead and do is I'm going to extend out here another foot. And so I have 4 foot by 4 foot capabilities. And I'm going to see if Certiflat will send me a 1 by 4 of this stuff, 1 foot by 4 foot of this stuff that I can mount down at a 90 from this surface, and then get one of their fab wings, and I can mount to that and extend it out another foot. And so I'll have capabilities of clamping stuff off of this surface up, and I can work on the end of stuff, or I could use a full 4x4. Even if I don't even if I don't do that and I just get the whole gantry off of here, I'll still have a 3 foot by 4 foot surface, and the axis, the rails and everything will be below the surface of this, so I'll still have all of my function of this table. I'm just going to have a big old glob of stuff hanging out over here. So I got my linear rail. I went with import stuff from eBay, and these are the Z-axis. I have all the stuff. These are 15 inches for Z-axis. I went with the round rod mostly for ease of use, and if I was to go with the that's the square rail and stuff, you got to be a little bit more dialed in, and any fluctuations, these round rails kind of help with not being in line and whatnot. These are the 16 millimeter rails. I was really thinking I was going to go with 20, but I ended up, I think the 16 will be just fine. The X and Y are 1400 millimeters, so 55 inches, and that will give me 55 inches. I want 48 inches by 48 inches of travel, and so that'll give me plenty of room, excess, that I could build a longer bearing plate that can give me more length over that 48 inches and more stability. The kit, it was a kit with the Z-axis and the ball screw, and it had 2 for X and 2 for Y linear rails, and I went ahead and got an extra set of 1400 millimeter rails, so I have 4 total for what's going to be the Y-axis. That way, there's a lot more stability there instead of just 2 there. If I had the fab block version with the perforated plate on the sides, it would be really easy project. I'm going to do a little bit of welding to this table to make this whole system work, but so the spacing on these rails is 30 millimeters apart, and the extruded aluminum would make stuff a lot easier with that T-slot, extruded T-slot stuff, but they don't make a lot of different options for 30 millimeter spacing, and then 30 millimeters wouldn't match up with your 2 inch spacing on this. So you could get different rails that have different widths, and somehow can configure an extruded aluminum that you can mount on the side, and extruded aluminum, and then you just get a bushing for this 5/8 down to whatever size hardware you're going to use, and be a complete bolt together system. But the way I'm doing it, there'll be a little bit of welding, and that'll be no big deal at all. So here's how I'm doing the X and Y, possibly the Z-axis. 1/2 inch by 6 inch aluminum plate, and bearing rails mounted to the plate, and then I can take another 7-inch section of that plate there for the axis to roll on. Initially I was thinking of going with this, I believe they call it architectural C-channel, so there's not a big old flange in here, and I could either go with both bearings interior, and then I could do like a bellow in here with the lead screw in here, and it would protect it. And there's a lot of options with the C channel. Like, you know, I could go one here and one here, and then take my excess C channel and flip it around, and the bearings would, you know, would be a matched set, so that C channel could slide along here like this. But I opted to go with this mostly for ease of assembly. So this is an example of one of the benefits of using one of these tables for a CNC machine is that you know, you got a lot of options for clamping and different job setups and stuff. These are Build Pro item, magnetic. These I believe are 1/2-13 threaded, and you know, they're with the magnet on them, and they just go underneath there, and you can put your bolts through. And this is from a set of T-slot clamps for a milling machine, and you know, with a 1/2-13 threaded stud, and you could, you know, clamp these down, and you have really a rigid clamping ability. Using one of these Fab Square fixtures, you know, I could hold something upright and say I wanted to do something, you know, at the top of it, you know, like say a wooden block or something, and I wanted to make a you know, a knob for the top of it or something like that. You know, I could use this plate here for holding that. Some of the cons that I see of using one of these tables is, you know, if you were to crash a tool into the surface of the table, that would kind of suck. But I don't plan to do any real close stuff to the table surface itself. I'll put you know, wood over underneath in between my work surface and or the, you know, the item and the work surface or the table. One of the other cons is it's not 100%, you know, rigid. It's got casters on it. I might swap them out for feet or. And then the other con, obviously, too, is price. You can, you know, build yourself a table for a lot less, but I think the versatility of this table outweighs the downfall of it being a pricey initial startup. So that concludes part one, and please like and subscribe.